Hello, my name is Soutaro. I'm an engineer working for Square in Tokyo. I write some Rails applications, and I'm also working to improve the development environment. I developed a type checker for Ruby called Steve, and I'm running an experiment to test Steve with some of the projects in the company. I'm also a member of the Ruby committed team, and I'm working for types in the team too. And yes, it is the topic of my talk today, the state of Ruby 3 typing. So let's start with what will happen in Ruby 3 about types. Ruby 3 will ship with a feature to support type checkers. It's called RBS. It is both the name of the language to declare types of Ruby program and the name of a Ruby gem bundled with Ruby 3. The gem provides features to read, write, and process the type definitions written in RBS. The type definitions of standard libraries are included too. So you can start using the library and standard library type definitions just after installing Ruby 3. One thing I want to note is that Ruby 3 won't provide something like the standard type checker. The Ruby committer team is not trying to say, hey, this is the best type checker for Ruby code. So you need to install type checker yourself. You need to choose the best type checker for your team and your project. I'd like to introduce the type checkers for Ruby you can choose. Steve is a type checker written in Ruby. This is my project. Sorbet is the most widely used type checker for Ruby today. You may find the talks about Sorbet in the program of this RubyKaigi. Steve and Sorbet assume that the users write types to type check the programs. Type profiler is different. It tries to infer the types in Ruby programs without any inline type annotations. Mame has a talk about type profiler in this Kaigi too. RDL is another project. This is a research project, and the development team led by Professor Jeff Foster published research papers about type checking for Ruby using that tool. The papers are super interesting. If you want to read the papers, you can find them on the internet. So we have at least 4 type checkers for Ruby. Let's start with the idea of the static type checking. This is an example Ruby program. We would have several questions. There is a new method called onConferenceConstant. You may have a question that, does the new method accept a string argument, or does the method require other arguments, like that? How about the talks method call? It uses the push method of the return value. So what is the type of the return value of talks method? It looks like an array, but it's not sure if it is correct or not. How is the each speaker method called? The method name starts with each, and we guess that it accepts some blocks. But what is the type of block arguments? Maybe an instance of speaker, but we don't know if it's correct or not. So like this, we find some questions when we are writing Ruby code, or maybe, of course, reading Ruby code. If we execute the Ruby program, the interpreter will answer to the question. It will raise argument error if the required arguments are missing. It will raise no method error if there is no method of that name. The block is a bit complicated. Ruby doesn't raise an error if an unexpected block is given to the method calls. But anyway, we will finally understand the problems if there is some problems, by running the Ruby program through tests or specs. However, what if we went to the answer to the question without running the Ruby program? It will a great experience if you write your code using editors or IDEs. Then some of the errors will appear right now. We don't need to run the tests, or we don't need to carefully read the source code of the library. So, static type checkers are the tools for this. It scans the Ruby source code and uncovers some of the problems without executing the code. And RBS is the data for the tools. I'd like to explain what RBS is. It is a new language to define types of Ruby programs. It is to describe API, the class and modules in the Ruby program, what methods and instance variables are available in the classes, how is the instance and mixing relationships between the modules and classes, constants, globals, blah blah blah, everything about that. This is an example of RBS for the conference class. It declares there is a class called conference. It also explains that it has two read-only attributes called name and talks. Name is a string, and talks is an array of the talk objects. The initialize method accepts one string argument, and each speaker method has two overloads. It accepts a block and it builds speaker's object. If block is not given, it returns an enumerator object. Using the RBS of the conference class, we can find the answer for the questions I explained in the first example. What is the type of argument of the new method? We can see the type of the initialize method. How is the talks method? We can find there is a talks method in the conference class, and its type is an array of talk. We find that each speaker method accepts block, and it builds a speaker object. The conference example is a very small example, but RBS can be used for the standard libraries. This is an RBS file for string class. This is a pretty long file, so you will find the list of the methods and the type of each method in that file. I want to introduce some of the advanced types of RBS. It has generics. The square bracket means it is a generic instance. We can write something like the array of integers or hash of string and array of integer or like this. Union types allows defining a type like string or symbol. It can be a string or symbol, but it cannot be float or hash. You can write union types in generics like array of string or integer. We also have optional types. It is a shortcut for union types with new. Integer question is an example of optional type. It can be integer or new. It allows type checkers to check if there is a possibility of calling a method on new. Interface type is to support duck typing. This is an example of the integer convertible interface. It has two int method. It means that any object can have the type if it has a two int method. No inheritance or mix-in is required. This is duck typing. Untyped is a special type that type checker will skip any check with the type. This is same as the any type in TypeScript. You can find more examples of RBS files in the repository. It contains the RBS files for standard libraries, RBS files for the RBS library code is included too. RBS is not a very big library, but it's a real Ruby program. It's not a toy example. I believe that it's a good example of how the real-world RBS files will look like. This is a quick introduction of the RBS language. I'd like to talk about what will happen to your Ruby project. Your Ruby application should use the standard libraries of Ruby, and you may install some gems for the project. And you define some of the classes and modules for your projects. I'd like to define 3 groups of types. Types for standard libraries, types for Ruby gems, and types for your applications. The first one is the standard library types. It includes the types of the standard library classes like string or array. It will be installed automatically when you install Ruby 3. The Ruby committer team is responsible for writing them, and of course we need some help from the Ruby community. And yeah, all of the Ruby developers will use the types. Gem types is the second group. It includes the types of the classes provided in the Ruby gems. It will be written by the author of the gem, or the community will help writing the type signatures. It's essential for the users of the Ruby gems. The type checkers cannot work well without the type definitions of Ruby gems. Third group is the types of your application. This is different from other 2 groups. It is about the classes defined in your application. The developer of the app writes the types, and it is used by the developer of the app. The writer and users are the same group of people. So the main targets of RBS are standard library types and gem types. I want to illustrate the situation that this is without RBS. Assume that there are several type checkers and they have different type signature languages. They need standard library types and the gem types. They make their own copies of the standard library types. Gem authors need to make different versions of the type signatures to support all of the type checkers. So this is not a good situation. What we want to do with RBS is to make it a common format of type definitions for the reusability of type definitions. We will provide type definitions for standard libraries in RBS, and we hope the gem authors will provide RBS for their libraries. And all of the type checkers can use the RBS files. On the other hand, the type definitions for application modules are out of scope of RBS. Type checker specific definition languages are totally okay. The developers of the application will choose the best type checker for their project. They write type definitions for the applications, but no one outside of the team will use it. Of course, each type checker will have different strategies for the adoption to RBS. Some of the type checkers will continue to use their native type definition languages, like the blue one in this page. Their language should have some advantages. They should provide some special features. We want them to support RBS types too, but we are not trying to duplicate other type definition formats. Or the opposite is it may use RBS for the application types too, like the purple one in this page. How is the support for RBS by existing type checkers? Steve uses RBS for the primary type definition language. It reads types for libraries from RBS files, and it uses RBS for application types too. Type profiler also supports RBS. It reads library types using RBS. It infers types of your Ruby programs without type declarations. So you don't have to write RBS of your application, but it generates the application RBS for you. Sorbet uses embedded DSL to write type annotations in Ruby code. They have a plan to support RBS too, but it may be only a subset. Some features of RBS may not be supported by Sorbet. So there are some levels of adoptions, but all of these type checkers support or will support RBS. So when we explain the idea of RBS, we receive this question frequently. So why it requires writing types in other files? Embedding type information in Ruby code would be better. So I'd like to explain the background of our decision. There are several reasons. We don't want to write types in Ruby code. Matt explained his idea several times that type annotations will be outdated in future, and then writing types in Ruby code is not a good way based on that idea. I'm not pretty sure if it could happen, but I also think that it is better to keep type checking optional. I know not all of the Ruby developers are interested in type checking. They are still skeptical if it works well, and I think it's good to make it that they can try the type checkers without changing the Ruby code. They add RBS files to the repository without changing the Ruby code, and if the type checking works, it's fine. But if they don't like that, they just delete the RBS files, and the rollback is done. Another one is more technical reason. We need to support Ruby libraries written in C. Standard library is implemented in C, and there are many extension libraries. There is no Ruby code for the libraries, so we anyway need a way to write types in another file. I also want to say that types in Ruby code is out of scope of RBS. It's not included in the spec. The type checkers can use inline type annotations if they need. And honestly, we know that type checkers need inline type annotations. At least both Sorbet and Steve requires writing type annotations in Ruby code. Sorbet uses Ruby DSL for inline type annotations. It embeds method type declarations in Ruby code, and it sometimes needs annotations like t.ret to specify type of an expression. Steve uses RBS for type of methods, but it uses comment for inline type annotations, like the declaration of the type of local variables. We don't say inline type annotation is a bad style or RBS is trying to replace it. It's just out of scope of RBS. It's totally up to the type checkers. So, this is an introduction of RBS language. It's a language, but it's also a library. RBS is not a static type checker itself. It's a library to help type checker and type-related tools development. So, this is an example of the components of type checkers. The list is not comprehensive. There should be something missing. But I want to say that we need a lot of work to develop a type checker. What we are interested in the most is type checking algorithm. We want to analyze the Ruby source code. However, we need a lot of work other than that. We need to define types, on the concrete syntax of the types. We have to implement parsers. We need implement many logics to validate the types or resolve type names, process inheritance, or how can we load type signatures for gems? And we need standard library types and gem types. RBS can take care of some of them. The RBS language covers these components. It defines the types and the syntax. We provide RBS library. We provide RBS for standard library. We believe that type definitions of gems will be available in RBS. And yeah, we also provide the RBS library. The gem provides some more features like this. So RBS can help doing these of the implement these of works. So you can just start working for the type checking algorithms. This is a small example of a Ruby program using RBS. It loads RBS files of standard library and the files from the sync directory using environment loader. Environment is a collection of all classes loaded from RBS, and definition builder is a class to construct internal data structure of classes. And finally, it prints the type of the gsub method of string class. I want to introduce some of the features of RBS gem. Writer is to format the AST to RBS syntax. If you want to make a tool to generate RBS, you may use the class. Prototype module includes some classes to generate RBS prototypes. There is a prototype generators from Ruby code and Solved RBI and Ruby's runtime API. It supports writing AST in JSON format. It has JSON schema in the schema directory, so I hope the JSON format helps working for tools by other languages. So, I explained that RBS is a library to help the development of type checkers and type-related tools. You would develop a tool to generate RBS, or you may want to develop new type checker for Ruby. Using the gem, you can skip working for some of the non-essential features, and you can focus on the development of core features. Of course, it depends on the design of your type checkers. Using RBS may not be the best option for your tool. But if you think supporting RBS is a good option, we believe that using that library will help you. So, this is the latest update for typing of Ruby 3. Ruby 3 will ship with a feature to support type checkers. It defines a language called RBS to define types of Ruby programs. It ships with a library to read the files, and RBS files of standard libraries are included. Ruby 3 won't have the standard type checker. RBS is not a type checker, and you need to choose and install the best type checker for your project. Thank you for watching my presentation. I don't think the RBS is perfect. There are many issues and missing features. Let me know if you find some questions or any feedbacks. You can reach me on Twitter or GitHub. So thanks again.